Okay, in this tutorial we will see how we can simulate the gallium antimony based solar cell. First of all, we open new project in the tool, click on tool. Here we have different tools for the geometry definition, for topping profile, for meshing, but we use STE. For meshing we have two separate tools, SN mesh and NOF set. And this is one for the Sentaurus device for the physics definition, what we want to simulate, either the solar cell, photodetector, LED, laser, diode, FET, BJT, and this one is for the electromagnetic simulation, and this is for the S-band simulation. So these are the three different tools that we are using for the study of the output. So click on SDE, okay. So this will appear two mode, mesh or interactive mode. Firstly, I will show you how we will use the interactive mode, and in the next tutorial I will show you how we use the batch mode. Okay, click on OK. The project has been added. The next step, we have to save this. So we save this project with the name of solar cell based on gallium antimony. Click it OK. So here we can see this project has been saved. The important thing, if we do all the things either in the command mode or on the graphical mode, if we don't save the project, and if we save the project in the end, sometime it will show some errors. So better to save the project first and then do all the simulation work. So next step, we will edit input by right clicking it, open the boundary file and open the command file. It asks us to save or create a new file. We click on yes. So this is the graphical user interface mode when we click on the boundary file. Okay, here we can make geometry, define doping, and each step that we are doing will be saved here, and we will copy these things and paste in the command file. So our command file will make the command file simultaneously by using this method. Now click on the exact coordinate system by this window, and after this we can define the 2D or 3D tool, 2D material or 3D material. So click on 2D, select the 2D region. Before drawing, we must select the material name. So for example, we are using one gallium antimony. Select here and click it here. So 0, 0, 2. So this is a vertex position window open. If we click here, if we don't click here, then this window will not be appear, and if this window will not be appear, then it will be difficult for us to manually interlink between two regions. So that's why we use the exact coordinate system. So this is the substrate, this is the epi layer, and light from top go to the bottom. The next step, we define the contact, but before defining the contact, we define some region here for the contact definition by clicking on the add vertex. Now we define it at 4 minus 0.2, okay, and then 6 minus 0.2. The 2 points have been selected. The next step, we will define the contact. Click on contact, then select the contact set and define the contact name, P contact, set it, and contact, and change the color edge, set it, close it. After this, click on the arrow here and select the edge because if we select the boundary, then whole boundary will be selected. Okay, click on the edge, contact, again open the contact set, P, activate it, close it, click on contact and set edge or set contact, both are okay. So first is okay, no, the P type is okay, then click on the N type, open the contact set again, click on N, activate, close it and set contact. Now the both contact are defined for P and N side. Now we define the doping. For doping we have these four options, but the simplest one is the constant profile placement. I will show you for the constant profile. So here we have 3-4 further options. If we have more than 2 materials or 1 or 2 or 3 materials, the list is above shown here, but currently we have 1 material, so 1 material is selected. But if we have click on region, we have 2 region, region 1 and region 2. So select region 1. This name can be changed according to your will. So if we don't name what is the dopant distribution, what is the material element add in the material for make it P or N type, the simplest way, click on other, select dot P, highlight it, close it and define the concentration value, click on add placement. For the next one we must change the name. If we don't change the name, it will overlap with the previous setting. So click on N. So we have selected 18, 3, add placement. Now the doping definitions is complete. The next step, we have defined the meshing. There are two tools that we can use for the meshing: refine placement and the multi-box placement. If we use the meshing tool separately, then we have defined the tensor parameters for the optical simulation. But here we use the simplest one, define placement. We can define the one placement by adding material, or we can define it by region 1 or region 2. For the optical one, we have the maximum and the minimum of X. Similarly for Y, we will fix it for 1 nanometer. For fine meshing, click on add, and similarly for the second one, we will use this. Okay, add placement. Now the doping and meshing is defined. The next step to see the meshing. Before meshing, we must save the project. If we click here, we have the default name as DE model. So we must close it and save the model with the name of N1. Similarly, again open file, save boundary file with the name of N1 and save boundary file as a TDR format with the name of N1. Okay, now the model is saved, and if we click on mesh, build mesh, now we have the mesh name. Open in the type plot and click on build mesh. Okay, the next step, before opening this window, what we will do, we will copy all the commands and paste it in the command file. And in the next tutorial, I will show you how we can modify these commands, and by using these modification in the command, we can run the program. So now we are waiting until the text plot will be open. Just wait, it will take a little time. We are waiting for this one. Okay, now in the next tutorial uh, I will show you how we can use the interactive mode and how we can use the batch mode. So this, it will take a lot of time, so we are still waiting until the tech plot will not open, and second I will copy all the commands and paste it in the command file. Still stuck in